So in this video, I'll be discussing the utilization of factorial designs and a unique technique that will basically allow us to reduce the size of them. So fractional experiments are useful when an experiment has two or more factors that have multiple levels, basically. The problem is if there are multiple levels and multiple factors, the size of the general factor factorial will be extremely large. So one technique when dealing with large factorial experiments is to utilize fractional replication. Basically, fractional replication is useful in very large experiments where a single full replication would be too large for a company or expensive to evaluate with the available resources that they have. So instead, we are able to basically take a fraction of the replication and still receive the desired accuracy as if they were the whole experiment. This technique will basically allow more factors to be included within an experiment without increasing the number of observations. So let's consider a full factorial model in which we have 5 factors. This particular example is a 2-level 5 factorial design with a total of 32 runs. Using a full factorial model, we are able to evaluate a number of interactions that occur, but take a look at it and what do you notice? The fact is that in a way we don't care about the higher interactions that are repeated. So often they are negligible, so allowing us to reduce the number of runs while getting the main effects and interactions that we're interested in while ignoring the higher interactions. This is basically what fractional replication deals with. So when dealing with 2-level factorial experiments, the levels of a factor are often referred to as +1 for the higher level and -1 for the lower, just so you guys don't get confused about the plus and minus. So some examples that you might see if you look it up, they also include letters like A, B, but we're only going to deal with the numbers to represent the higher and lower levels. In this example, we are examining a 2-level half factorial design with 3 factors A, B, and C. When generating, we're set up basically we're set up with ones of each factor so that every possible combination of A, B, and C are present. So you see we have -1, 1, -1, 1. You see how there's basically a pattern going on, 2 here and then 4 here. So basically the reason why we did this is just so we can get every possible combination. But here's the negatives of basically dealing with fractional replication of experiments. It's critical to note that when examining and wanting to include certain interactions, we sometimes see that 2 or more interactions appear to be the same, even though different factors are being utilized. So for example, let's take a look at A, B, and AC. You notice how they're the same. The problem is that when this occurs, we confound these results because we can't distinguish between the two as we basically could in a full factorial.